Hello, Brian Teague, Product Line Manager for Senko Advanced Components. And we're here basically working with one of our partners up here in Canada, Alliance Corp. And so we appreciate the opportunity that you're giving us right now to share some information about fiber optic connectors and Endface maintenance. If you've been doing fiber optics for a long time, hopefully we're going to give you some ideas and things that you can kind of take back to the workplace to help your team work smarter and help you have a better installation experience. And if you're new to fiber optics, we were going to hopefully give you some things to take into consideration so that as you go through and you start working with fiber optic connectors, that you're going to have the best experience and help you do the job right the first time. So with that, we're going to go to some slides here. And the first thing I want to share with you are some case studies and a couple of surveys. Okay, let's take a look at our first case study. This is one that was done by NTT East. If you're not familiar with NTT East, they are one of the largest fiber optic network carriers in the world. They have 21 million subscribers in Eastern Japan, and they cover the cities of like Tokyo, Chiba, Nagano. And what makes this case study kind of interesting is in 2015, their engineers decided to go and do a failure analysis. They went back and looked at the previous year's data to figure out what caused network downtimes or network failures. And so the objective in this study was to, once you understand what the problems are, then you can go back and start putting procedures and getting training in place to try to help prevent it so that you can have good network installation experience and also ensure that you have the best quality network. What was interesting was about 50% of the problems they had were cable related. This could be something where they ordered the wrong cable, the cable was pulled incorrectly, or maybe something just happened, somebody accidentally cut a cable. The other thing that was really interesting to me, and I think applicable to today's presentation, is they found that almost 40% of their issues were connector related. And so when they say connector related issues, it basically means that the connection point, they had high insertion loss or some reflectance issues. Basically, something was happening at the connectors that was causing a network problem and it had to be addressed. And then what I thought was also kind of interesting is then some of the other things like the device related issues, which could be things like a switch or a router, only accounted for about 9%, and then other were some miscellaneous events that happened. So the whole point of this is here it is, one of the largest operators of a high-speed fiber optic network is having the same problems like everybody else. And about 40% of the time, they're having an issue with fiber optic connectors. Okay, so let's take a look at a survey that was done a couple of years ago by the Light Brigade. They're one of the large training organizations globally that work with companies to teach installers best practices as well as network designers. And they had a survey where they asked the people to respond, which of these issues are you experiencing on a routine basis when you're doing a fiber optic installation? What I thought was very interesting, about 1 out of 5 were saying, hey, we have issues with dirty and damaged connectors. So that's a very significant number. And that it is actually backs up what we just saw in the previous case study with NTT East networks with the issues they were having. Another kind of note that I would found interesting about this particular survey is if you look at some of the other things that they have listed, for example, not sure how to use your OTDR, difficulty splicing. These are issues that are really training related. So if you can help your team understand how to use the gear that you've outfitted them with, that's important. And I would say also another thing is once somebody understands what it does and how to use it, they're going to be more inclined to use that particular tool that you've given them, and that's going to help them be a lot more successful in the installation. Other things like excessive loss and high attenuation. I suspect some of that also kind of ties into some of the issues you would see with connectors. For example, dirty connectors are going to increase the insertion loss because you're going to have the contaminant causing a problem, either where it's totally blocking the signal or it's absorbing some of the signal, and so you're going to see the insertion loss go way up. Other things too, like where they're saying, hey, they have issues with pulling and installing cables, are also improperly labeling cables. These two may be kind of things also related to connectors, because if you think about high fiber counts, it's important to make sure you have things connected correctly. And if somebody's going through and they don't understand the polarity and they're plugging and unplugging, thinking that it's some kind of polarity issue or something else going on, what they're doing every time they mate and demate those connectors, it generates wear debris and is potentially putting contamination on there. So a lot of these issues that we're seeing may also be contributors to why we're seeing a lot of people have damaged and dirty connectors. So again, this is one of the reasons why it's so important to make sure you start thinking about connector interface, basically maintaining it and what to look for. Okay, so hopefully at this point you're starting to see, hey, fiber optic connectors are something that we need to start thinking about when we're doing our optical network. So these are areas basically where you're bringing two pieces of the network together. Connectors in themselves are not bad, but one of the things we are seeing is a lot of people just are not doing, let's say, the best job of maintaining the connectors. So here's a couple more things when we start thinking about, hey, I don't have time to do this, or I don't want to mess with this. Let me show you what the cost is if you start neglecting your connectors. Okay, so here's our second case study. Now, these are values that have come from a construction contract with one of the major U.S. carriers. So I don't upset anybody. I decided not to share which of the carriers it is, but I suspect that what you're seeing here is fairly common throughout the industry. When you see a lot of people talking about truck rollback expenses being somewhere in the $150 to $300 range. I understand sort of where those numbers come from, but I would say in reality, I think those numbers are way low, very low. And the reason being is when you start looking at what it costs to send a technician out with the truck, yeah, it's expensive. However, most issues don't normally happen between normal working hours. So if you have something that happens late in the afternoon or in the evening, it's more expensive for after hours. If you have something that has to be done over holidays or during the weekend, it also will increase the labor costs. There are also some instances where if you have your contractor that's got multiple projects going and you need to change and get something expedited, they charge for it because it causes them a lot of extra expense to have to reallocate resources and move things around. So that's why some will have an expedite work charge. Typically, a lot of the companies, at least in the States, and I suspect it's probably fairly common in Canada, probably have in billable increments like 2 hours. For example, I know when I go to the mechanic to get my car fixed, even though it may take him half an hour to fix it, he charges whatever the labor rate per hour is in the book. So sometimes we're just kind of stuck with that. The other thing too that can also add to the cost is if we have to sit there and get new equipment in, things that can take longer times to get the network fixed is if we're waiting for parts. So sometimes we have to order things from suppliers. We may have to run back to the garage and get something else. So these are additional costs that don't always get captured in that $150 to $300 truck rollback. So the whole point of this is it's important to make sure that you're doing everything you can to do the job right the first time. And things like managing the connectors, for example, inspecting and cleaning the connectors is a very quick and simple process. Yet so many guys will say they don't have time to do it. But yet, if you look at the cost of a failure, it totally evaporates any savings they thought they were going to have. And in reality, we're seeing that, damaging connectors because of contamination is a fairly common problem. Now, there's always going to be some things that we can't handle or control, right? For example, storms, or somebody has an accident, hits the pole and knocks the cables down, or the construction company forgot to call before they dig and accidentally do the cuts. So you're always going to have some of these repair costs that you're going to have to deal with. But anything that we can do to try to get some control over that so we can better maintain our costs is a good thing. Whether you're the construction company that's having to do the work and have to do the repairs, or whether you're the end user the carrier who's sitting there that's hired these companies or sending your own people out to do the repair work. So again, anything you can do to better control that cost is going to help you not only have a better network, but you'll have a better installation experience. And the other thing too is you'll basically make sure that you have happy customers, and that's really the goal here. Okay, here's the last survey I want to share with you. Now, this was one that was done by the Uptime Institute for 2020 for their data center survey. So I'm going to share a couple things that stood out. I think if we were to do the same survey with carriers that are doing, head-in or central office projects as well as outside plant, I suspect we would see probably similar numbers here. But the first one that kind of stood out to me was we're noticing a trend where the managers are realizing, hey, are the incidences that we're running into preventable? So in 2019 and compared to 2020, we're seeing people becoming more aware that, hey, a lot of the problems we're running into are preventable. And so again, working with fiber optic connectors, most of the problems that you're going to see are avoidable. So that's the good news, right? We can go through and we can have a positive impact and bend that curve back so that we're better controlling our costs. Now, the other question that kind of caught my eye that I thought was interesting is if you look at the comparison between 2019 and 2020, people are becoming more aware of what the true cost of a network outage is. So yeah, some of it may be we're sending more data down the line, but I think also we're becoming more aware, just as we saw from the previous survey about the cost of a true truck rollback, but also we're looking at it. The reason you want to make sure you're maintaining your connectors well is it's not just the direct impact cost, but also your opportunity cost and reputation. If you're a construction company, you don't want to be the guy in town known for doing shoddy work. You want that good reputation that everybody calls you and wants you to come do their projects for them. And also from an opportunity standpoint, if you're having to send your crews back to fix things all the time, you're not going to be able to take on new jobs, and that's going to hurt your chance to grow and bring in more revenue. On the flip side, if you're on the carrier perspective, you want to make sure that your team and the companies that you hire to do the work for your network do have good skills and are doing the job right the first time. So that way the subscribers get the service turned on and it works exactly the way that they hoped. You don't want something crazy like a dirty connector frustrating somebody. That's just, and it doesn't have to happen. So the key here is just remember a lot of problems are preventable. And the other thing too is by focusing on that, we can actually, again, have better control of our costs. So there is a lot of good stuff that we can do. So let's get into the next part of the program. Now, since we know that fiber optic connectors can be one of the challenges on our network, and we need to be focused on ways to proactively ensure that the Endface quality is good, the easiest, most simple way to do it is use one of these. This is a feral inspection scope, and this is a digital one. And when you go through and do the analysis, it actually takes the human subjectivity out of it. So basically, the software that comes with a scope measures the Endface quality. So it's measuring any defects from contamination to also scratches or pits in the Endface to let you know whether it's going to have a problem. So what does it measure to? Let's take a look. Okay, when you're working with fiber optic connectors, it's important to always make sure you check both ends. Now, one of the things that I found that makes things really helpful is I like to always use the in adapter tip when I work, because it allows me to check the connectors inside the panel, and then also I can very quickly check jumpers using another adapter. Adapters are pretty inexpensive, and this saves me from having to swap back and forth between tips. Also, like here, we're working with some SCAPC connectors. Using the adapter takes advantage of the connector key so that way the angle is always lined up with the one in the camera. So let me show you how quickly this would work. If I were checking the connectors inside the panel, this would be my connector. So what I would do is right before I'm ready to mate, I remove the end cap. I check. In this case, I just push the button and we can see what the Endface quality is. Come to the other side and let's check it. Excellent. Okay, now I need to go through and make sure I check the jumper. So in this case, I'll use my extra adapter. I take the end caps off and I'll just plug it in very quickly and check them. Okay. All right. So we know we're going to have to do some cleaning. So let's take a look at that. Okay, so we know after inspecting the interfaces, we're going to have to clean the connectors. Now, one of the questions that comes up all the time is, hey, which cleaner is the best? Which one should I use? And the answer is it really kind of varies. It's going to depend on how much contamination you're dealing with. There's also different processes that you can use for the different products. One of the most common ones that are out there are these mechanical cleaners. So the way that these guys work, it's a push engagement. And the reason these have been so popular is because of the way they're designed. So they're designed so that you can clean the connectors inside the adapter port as well as clean the cable assemblies. So one tool does the self-alignment and works for both ends. Another option that's very popular or starting to grow are some of these mini cleaners. And so these mini cleaners work the same way. It's a push engagement. They're just a little bit smaller, but the reason you may use a mini cleaner is if you're dealing with connectors in confined spaces. For example, some of the cable system makers out there are now starting to make panels that are a lot smaller, and so it's harder for the standard reach tools to get into. So these mini cleaners are a great option as well. They tend to have fewer cleanings, but they can get you in the spaces that the regular standard length tools can't get. Another option that people always love are the cassettes. So the cassettes, like this is one of the Cleatop S. It's been around forever. The way it works, it uses a push engagement, opens a shutter, and you can wipe your connectors. But there's other versions as well. You also have, like, this is an OptiPop cassette. So even with cassettes, there's different options. And there's even one now that actually has an open window, and you can manually turn the wheel to get the cleaning ribbon to where you want it to go. So even with cassettes, there's a number of different options that are available. They all use this micro fabric material that is really good. It's got very good absorbency, and you can use it by wiping connectors dry, or you can use the wet to dry by applying a small amount of solvent. Another common one is the cleaning stick. So there's a number of different cleaning stick options that are available in the market. You use things like the cassette to clean your jumpers, because you would have to open up the fiber management panel to clean with this. So jumpers are usually what the cassettes are best for. And then you have the sticks. And the sticks are good for cleaning connectors inside the adapters, as well as if you're dealing with some of these multi-port type of enclosures in the outside plant for cleaning the end faces inside the multi-ports. One of the advantages that the sticks have is that they will go through and clean the sidewalls. So as you're turning the stick, the best advice I can give you is make sure you rotate it about 4 to 6 times in the same direction, using the same amount of pressure you would like if you were writing your name with a pen, and then you only use a stick one time. So you can use sticks. There's also ways that you can use the stick. These particular sticks I have here, some of them have that same cleaning ribbon material that you can use for doing a dry clean. That's the same white process that you would get from the cassette, or you can even put cleaning fluid on it and then apply the fluid, breaks it up, and then come in with a secondary stick to wick it away. So the whole thing here is there's many different options that are available to you. So the advantage that you have now for cleaning connectors, it's not one necessarily is better than the other, but what you want to do is think about what your situation is, like how much contamination am I dealing with? What is the skill of my team that I'm working with? Do they have a lot of experience, or is this kind of new to them? If it's kind of new, using things like the mechanical cleaner are great because, again, they're self-aligning. If they have a lot of experience, or you're dealing with something with a lot of heavy contamination, maybe using some of these products like the cassettes or even solvent and wipes would be a good option for you. If you're having to do any kind of like splicing, so if you're splicing pigtails onto bulk cable, using fluid and wipes would be a great option. And you can also use that to do a wet to dry cleaning method. Okay, so let's go back to our original inspection when we looked at the 4 SCAPCs. Here's a collage with all 4 images together. If you notice, each one of these has some blue rings. So let's get into what are we looking at with these rings and why it matters. Okay, so here's a bigger image of one of the connector interfaces that we looked at. If you notice, there's 4 blue rings on here. Each one of these blue rings is a different zone. These zones are dictated by the IEC 613-00335 standard, which talks about surface interface quality. So let's just look at the zones real quick. The first zone in the center is the core. So this is the fiber core where the light goes through, and it's about 9 microns. The next circle that you see in there, that's the cladding zone. So the diameter here is 125 microns. The third circle that you see, that's the epoxy zone. And the fourth circle, that's the contact zone. So that's 250 microns. We'll get into the different zones in the IEC in just a second and how they differ between single mode, multi-mode, and single fiber and multi-fiber. But I wanted to show you this quickly because most automated software systems from the digital inspection scopes will usually defer to the IEC standard. And so when you see these circles, what it's doing is helping you understand what the surface quality is based on the pass-fail criteria of that standard. And so anything that is identified as a problem in that area is something that's going to need to be addressed. So if it's contamination, we need to clean it. If it's a scratch, we'll probably have to replace it. In this image, we can see it's got a little bit of residue, which the software is picking up is identified in red. Here's a view of a ferrule interface using an interferometer. So what an interferometer does, it's usually in the cable assembly shops, and they use this to measure the geometry of the interface. But I wanted to show this image because I think it will help you understand kind of what's happening on the ferrule interface. So if you see there in the center, you can see where the fiber is. And then if you notice, it looks a lot like a topographical map where you can kind of sort of see how the edges sort of radiate down, right? And that's really what's going on the connector. So when the IEC standard is looking at different regions, it's looking at the contact region. And let's take a look at what the different regions are. Okay, what we're looking at here is kind of a quick graphical representation of this IEC standard. This IEC standard is basically looking at the contact region on the ferrule interface. So it's going to vary depending on whether you're dealing with multi-mode fiber or single mode fiber. It'll also, depending on surface defect measurements about what's allowable, it's going to vary a little bit between UPC and APC for single mode when it comes to polish. And also, if you're dealing with MPOs with multi-fibers, they have a 2-zone system versus the 4. Now, there are some groups that are saying, hey, we need to look at the area outside of these 4 zones. And there is some merit to that. However, for this discussion, I'm just going to focus in on what the standard says because these are measurable defects. And the defects that are allowable or beyond the tolerances of what is allowable are known to impact the optical performance. So for example, a scratch of a certain size in a particular zone that is beyond what the IEC allows is known to create higher insertion loss or may end up causing problems with reflectance if you're using APC connectors. Issues outside of the zone are not really going to have an optical impact. However, things like contamination could potentially migrate in if the connectors are not mated quickly. When 2 connectors are mated, material or contaminants outside of that contact region don't matter because the contact force is so strong, you don't have to worry about something migrating into the connected pair. It can only migrate in when the connector is unmated and is exposed. So as long as you clean before you connect and the contact region is clean, you're going to be okay from an optical performance standpoint. Okay, so now we've covered the different cleaning options and well is also what we're looking at when we inspect the connector interface. So let's go back to our pair of SCAPC connectors. It's time to clean them. So let's go through and look at 2 different ways to clean them using one of the mechanical cleaners. Okay, now we need to clean our connectors. So we have 2 different ways we can do it. The first one is doing a dry cleaning, which if you're dealing with a connector that has been just subject to maybe light level contamination in the central office, this works great. And they all work the same way. You put the connector inside of the port, you give it a push, then you always want to make sure you clean the other end. You open the cap, get to the connector, give it a push, and you're all set. Now there may be times when you're having issues with static, and that's when you'll start to see dust again and again coming onto the connector end face. Also, if you're working in an outside plant, you may have times where the end face has a lot of heavy contamination. So in this case, you may want to do a wet to dry. So what I'm doing here is I'm taking my wipe, I'm applying a small amount of solvent to the wipe. I don't ever want to touch the solvent directly onto the cleaner because it could flood the end face. So once I have my wipe with a little bit of the moisture, I touch my end face into it, and I would go through and clean just like I normally would. If you're cleaning the jumper, it's the same process. Wet the tip, put the cap on, and give it a push. What the solvent is doing is breaking up any heavy contaminants that are on the end face, as well as creating a dissipative medium for the cleaner to eliminate the static problem. Okay, so now that we've cleaned our end faces, now let's go back and double check our work. So again, doing the same process as we did before. You come in, push the button. All right. Let's check this one. Push the button. Good. Okay, so doing like we did last time, I'm going to use my adapter to check my jumper in. Let's check and see how we did. Okay, looks good. And the last one. All right, so everything looks really good. We know that both ends are clean, and we can safely mate the connectors together. Voila, you're all set. Okay, so I know the majority of you out there kind of sort of like the click style cleaners, and those are great tools. But there may be sometimes too, like we talked before about using a cassette or using sticks. So what I want to do is just kind of go through and give you a couple ways to effectively clean using a cassette as well as using a stick. Now remember, we use cassettes to clean connectors that are unmated by wiping, and also we can use the stick to clean connectors inside of the adapter. So I'm going to go through and show you a couple techniques on that. Hopefully will help you get really good results. Okay, so first we're going to start looking at a cassette cleaner. So there's 2 ways you can do it. If you want to do a dry cleaning, and I'll use this particular cassette, this one advances the cleaning ribbon every time I pull it out. So I do that, I start at the top and go across. You only want to wipe it one time. You don't want to go back and forth, because if you do, you could end up putting contaminants back on. Another way to do it is if you wanted to do a wet to dry, you could use this manual cassette where you advance. Again, if I were going to do a wet to dry, I would take my cleaning fluid, put a small drop on there. You don't need a whole lot to make it work. Then take the connector end face, start with the section that's wet, make sure you get the angle right if you're doing an APC, and wipe it across one time. That's all there is to it. Okay, so another way to clean the connectors is also going back old school. We can do it with the wipes. When I pull a wipe, what I want to do is make sure I use an optical grade wipe. And I only want to pull one wipe out at a time. When the wipes are not in use, you want to keep the bag sealed to keep it from getting cross-contaminated. Now these are a 4x4 wipe, which are pretty common. And what I'm going to do is I'm going to fold it in half. I'm going to take my cleaning solvent, put a small amount of the fluid up at the top, take the connector, put it into the area that's wet, and then wipe it towards the dry. You want to be careful not to oversaturate. If you're using alcohol, which I know is very common, make sure that you change your alcohol out on a regular basis because it's hygroscopic. It can create moisture. Okay, so now I'm going to show you some techniques for cleaning with a stick. Now, not all sticks are made the same. So the sticks that I have here actually have the ribbon cleaning tip on them. So you can use these dry. they have the same microwoven material that is used on the cassettes. So the way this one would work is if I were going to clean my connector inside the adapter, I just put it in like I normally would, turn it about 4 to 6 times in the same direction, and that's all there is to it. Now, if you are working with a stick that does require solvent, it's not a big deal, and I'm going to show you a real quick way to do this. Some of the sticks that you have out there are cotton-based. I would stay away from them just because sometimes they tend to leave fibers behind, but a lot of materials that they have out there are really good. If you're going to go through and do the stick, what I would do was take my solvent, grab a wipe, and use a similar process to what we did with the mechanical cleaner. Touch the tip of the stick, and so in this case, I'm going to clean the port of one of these multi-port enclosures using the same process. And we're all set. So the key is don't reuse sticks, only take one stick out at a time, and when you're using solvent, make sure you don't oversaturate the tip. Okay, so we've gone through, we've talked about inspection, we know how to do it, we know what we're looking at, and we know the applicable standards. We've talked about different cleaning products, about what options are available, whether when to use a cassette or a stick or a wipe or a mechanical cleaner. And we've even gone through and shared some techniques that hopefully will help you have a good installation experience. Now, before we finish up, I do want to address one of the concerns that I hear on a regular basis. When I talk with people, why don't you do inspection and cleaning? And the number one answer that always comes back is I don't have time. So my response to that is, if you didn't have time to do it right, do you think you're going to have time to fix it, right? So let me just show you real quick what happens when you choose to skip the inspection and cleaning process. What's going to happen to your connector interfaces? Okay, so here's an example of what happens when you choose to skip the inspection and cleaning process. Remember we talked earlier at the beginning of the presentation about how connector problems can end up causing high insertion loss and mess up reflectance values. And this is how this happens. What I did is I took a clean connector, connector 1, and I mated it to connector 2 that had a little bit of dust on it. The dust that you see here isn't severe. It would be something that you may expect to see with connector wear debris or a connector that's been just kind of dangling or exposed for a little while. Not too severe. Now at this point, if I clean both connectors, I would not have this problem. But what I decided to do for this example is go ahead and mate the two. And then I inspected it. So in the center, what you can see is the dust from connector 2 has now transferred over to connector 1. And also the dust has started to break apart. And so it's spreading across the ferrule end face. Now I went through and tried multiple times to clean both end faces, but unfortunately some of the dust isn't getting out. And it's because it's become embedded into the surface of both glass and ferrule end face of both connectors in the pair. When this happens, there's nothing you can do. You're going to have to replace both connectors. So any time savings that you thought you were going to have and any cost savings that you thought you're going to have will be lost when you have to go through and replace both of these connectors. Here are two end faces that we measured on an interferometer that have dust on them. And the reason I want to show you this is so you can kind of start thinking about it. You can see the topography of the ferrule end face where it kind of looks like a dome on both of these. And both of these isometric images that we took on the interferometer I think are pretty good because they show you what contamination actually looks like. And if you think about it, you can kind of sort of see it looks like ridges or bumps on the surface. And so any of this debris that doesn't get removed is going to get basically compressed, and this is how it ends up embedded into both end faces. So this is why it's so important to make sure that you have a proactive inspection and cleaning regimen before you start mating connectors, because what will happen is over time you may get away with it for a while, but eventually you're going to end up tearing up the end faces and having problems. It's happened to one of the world's largest carriers, what we saw earlier with NTT East. It happens on a regular basis in many different applications, from data centers to aircraft to carrier networks. So again, dust is out there. It's going to happen, but again, you know some good techniques and you know some ways to identify and how to eliminate it. So the key is, again, to be proactive. Okay, so now here we are at the end. I want to just kind of remind you that the best thing you can do working with fiber optic connectors is make sure that you have a good proactive inspection and cleaning regime. While we took a little bit longer to do these things in the videos, in reality, you're probably only looking about 2 seconds to inspect an Endface for a single fiber. The same thing too, about 2 seconds to clean a connector, whether you're using one of the mechanical cleaners, a cassette, or a stick. The whole process actually goes very fast. If you think about the amount of time it's going to take you to fix something, so as we just saw, if you end up having contamination and you make the two connectors, you're going to end up damaging both of them. You're going to spend more time either splicing or putting on a field install or actually having to run another cable assembly than you would if you'd have done it right the first time. So again, the best thing I can encourage you to do is think smart when you're working with fiber connectors, be safe. And if you have any questions about any of these products, I encourage you to reach out to Alliance. It's one of our partners up here in Canada that has all these products. All the products that we've shown and a lot of these materials that we have to try to help you work smarter at your job. Those folks over at Alliance will be happy to help you. The same thing too, as we wrap up here, I'll leave my email and phone number that if you have any questions or comments, please feel free to reach out. If there's anything we can do to help you to have a better installation experience, and if you need assistance working with fiber connectors, I encourage you to please reach out. Folks at Alliance as well as Senko are here to help you. So again, thank you for your time. I'm sorry I couldn't be here with you. Trust me, I'd much rather be up there with you guys. And I appreciate your time, and I hope you have a great rest of your day. Hey, that's all for now. Thanks a lot. Take care.